All right. I think we're ready to get started. Hi, everybody. Super awesome that so many could make it. Yay! My name is Johan Ramstrom, or as you pronounce it in Swedish, Johan Ramström. It's a bit weird. I think I'm probably shorter than the average American, because I feel like I'm disappearing behind there. So if I'm on the side, you know why. It's to make me feel taller. All right, I'm here today to talk about rigging in Battlefield 3. I've been working with animation for over 10 years, and I've spent 6 of them at DICE, most recently on Battlefield 3. So rigging for us at DICE have been quite different from movies and high-end productions, as we've been quite limited by technology and the number of bones you can have. But with the new Frostbite engine and our Ant system, I think we are kind of changing it, and this is what I'll show you today. Today we will talk about the rigging in the pre-production, what we did before we started this big journey of Battlefield 3. I'll show the character builder, which is our main rigging tool for putting a lot of components, a lot of modules together into one single animation rig. I'll show the weapon builder, which is exactly the same, but it shares the same foundation. It's just customizable for weapons. I'll show the face poser animation setup, which is awesome. It enabled us to have one single animation, and we could share it and retarget it to any kind of head. It is super awesome. I will show you. I'll show you the animation pipeline and how we get all these kind of assets into the game, and how we work with the animations. And of course, what we learned doing all this. But first, let me show you what this is all about. Lights, please.
آماده بجم. Shame. You come to our country to murder us, yet we are the terrorists.
All call signs listed. We are mission launch. Repeat, we are mission launch.
18 hours ago, I get a call from Homeland Security saying there's a Marine in detention I need to talk to.
Gentlemen, as you know, we're dealing with insurgents crossing over from Iran.
You want us to believe that there's a PLR threat and Solomon's at the head?
You're the quick reaction force, gentlemen. Trusting you to handle this.
The nuke is still out there. Can't just walk away from the threat.
Let's go find our Marines.
I said get down on the ground!
Trial, you are guilty. I know how your fucking story is.
All right. That is it. So, what we all were thinking, what on earth are we getting ourselves into? This is quite a big project, so we had to try a lot of things. In pre-production, we have to be aware, design will always change. I'm sure everybody who's working with a creative project has experienced this. Nothing is never finished, ever. There is no final character or no final concepts. All you can do is live with it and make sure that your rig or your animation pipelines can deal with this. It is the only thing. It's the way it has to be. Prototype everything. This is another classic. You say it all the time. You hear other people say it, but we never do it. We prototype some stuff, but we forget half of it. But we really try to do this. And when you're developing a rig that's going to be used on 4 to 5 to 6,000 animations, you have to make sure that the animators are with you on the same page and on the same boat. So you need to get the animators' feedback super, super early as possible. If you can spot anything like the hand is off or the foot control is the wrong color, you need to fix this in the pre-production. You can change this in the middle of the production, but I will never recommend it. It is horrible, horrible. And another thing we took a hard lesson on was the anatomy reference. You have to be super, super careful about this. When you design the new game and you have the new concepts and you come to the animators or riggers and say, hey, we have this amazing character, can you rig it for us? And the spontaneous answer is, of course I can. I'll do it right away. I'll come back in a couple of hours and I'll do it. But what you really need to do in such a huge production is to make sure, is this anatomy correct? And will it work? Is the arm's length proper? And you need to sit down with the art director and you need to show him, okay, how will this crazy concept of 3 arms, how will it move and how will it interact with the environment? Oh yeah, show it. So, nobody's going to do this before you. It is you in the rigging team and the character team who really have to push for this. You need to make sure that you get a model, that you get a blueprint. This is our main anatomy. This is a dude with 2 arms, 2 legs, and it's going to look roughly like this. And this is something that we paid a high price for, but we learned from it and we did it. So this is what we used at DICE. We got ourselves a scan of a model just to make sure that the anatomy would be correct. So nobody can say that, hey, that guy is not real. He is. We scanned him. His name is George. I have no idea. Here you can see the joint placements and all the controls and everything. We even bought ourselves a scanned human skeleton. It's from medicine education, don't worry. We didn't scan it ourselves. So we had a human skeleton just to make sure that our joint placement was spot on. And it is super important. You get a feel for how it looks. You can put anything in. You can have military clothes. You can have a dress or whatever game you're making. But beneath the surface, make sure you have a solid anatomy. And if we're looking at the skeleton, I see if it should come back. There's actually, the final skeleton landed on 211 joints with all the deformation joints and all the fancy stuff. And with 64 players on the screen, that is 13,504 joints. Pushed real time, every frame. Pixar, here we come. It's getting there. So, how do you start off a rig like this? We have a tool called the Character Builder. Fancy name, I know. It takes a whole bunch of components, puts it together. In this case, it will list all the rigs in your project, and it will give you 3 options. You can create a new rig, you can edit the existing one, or you can rebuild a bunch of them. So we're going to start with creating a new one. You bring in your model, and there's not really that much to do. You press the only button. This button will clear the scene and make sure that, okay, the model is the right size, the junk and the history, nuke it, make sure it's ready to be rigged. Awesome button. The import rig will bring in a predefined template skeleton. And depending on how this skeleton is structured, it will generate these controls for you. And you position the joints where you want them. You scale your controls, you rotate them around just to fit your character. You hit the Save Rig button. So this will save all your changes into a few separate files. And this has been a huge win as well. Having all your user-modified changes as external files on the hard drive is awesome. It means that you can copy settings. You can copy like the control configuration from one character to another. You can copy the joint placements from one to many. It's really great, and you can have it in perforce and backup and revision history. So once you're saved, you go on to the skinning part. Nothing really fancy here. Everybody loves the skinning part. I know, we do. We use Maya's native copy skinning a lot. Since we did a lot of groundwork with the anatomy reference, we skinned that guy so many times and so many iterations. We were spot on with the skinning with it. We were so happy with it. So once you have done this one time, you can reuse the skinning on the entire project. So we copied it from the arms. You can even use like vertex. I copied just the fingers from this one, and I can copy the finger from another one. And you can save so much time by doing this. And we even enabled our character modelers to a simplified version of this tool, which means that the character modelers could take any jacket or hat or character. They could press a button. They would bring in our anatomy reference with the little test animation on him. They could copy the skinning instantly, which means they get a rough skinning, a rough start. They get 80% or even 90% in some cases, skinning-wise. They could export it to the game right away and see the character in 1 minute. And this is really awesome. Even if the skinning is, it's a bit rough around the edges and stuff, it doesn't matter. They can see it, they can test it in the game, and see how it feels and moves and interacts. Super important and awesome. So, this is what the final rig looks like. A bit low res, but you get the point. It is mirrored controls and a few fancy stuff. It is has a few. It has a grouping hierarchy, which just sets up the scene and puts every control in the right hierarchy and stuff. It has a spline IKFK for the back. It has a head, of course, a face poser component, which I will talk about soon, and some IKFK stuff. It's really basic stuff, but it's putting it together and making it one piece that is important. So, if you make this easy enough, and you give it to the character modelers, this is what you end up with. So even some animators tried it on their personal projects, and some character modelers like, hey, I want to try this rig on my dog. Yes, go ahead, it's fine. And they did it a lot, and it's super awesome. They can just get it into game, try it, see how it feels. And this is why you should make the tools super, super easy to use. Anyone can try it, and you'll see awesome results. Same thing for the weapons. As you can see, there's quite a few weapons there. I think we were over 100 weapons in the end. If these tools were harder to use, I would be doing nothing else than rigging weapons. I've been rigging weapons for 2 years. It's not possible. So, same thing there. It's built on the same foundations. You can edit the weapons. You can rebuild all of them, create a new rig. And you can also specify that since we are using one skeleton for all the weapons in Battlefield, so we are sharing the same skeleton, we needed to be able to customize. It was a huge skeleton, I can tell you. It's like the ultimate weapon skeleton. It's awesome. But you could customize every control. You could say, okay, in this weapon, I want the slide to be able to have only the translate C or whatever. And you could have the trigger for one just being rotated. And you can reuse the trigger somewhere else if you wanted. It really worked well. And we had all the animators rig their own weapon. Animate it themselves, export it themselves. Super awesome. All right, this beautiful thing. The face poser component. This little thing saved us time, it saved us memory, and it increased quality on the same time. And it's really, really simple. You take a head, you give it a set of poses. We landed on 94 poses for every head. You can get lower, but we're a bit quality crazy at DICE, so we had the 94 poses. So you go through the list of all these poses, and you customize them per character. We always start off by copying the default, or copying another one that we were happy with. All right, start off with George, and we make him into Jeff, and iterate on this process a lot. So it is based on the facial acting coding system. It is a system used for categorizing emotions. So it's a very generic. It's like brow up, brow down, jaw open, and all these kinds of stuff. So the animation that then is applied onto the animation is just float attributes. So when the animator says, all right, I want to open the jaw halfway, the jaw open attribute goes to 0.5. The 0.5 animation channels are then exported into the game, and the game has a copy of these poses. So it blends real-time into this pose. So that we are never exporting the animation is never the facial joints, it's only float attributes, which are then used in the game. So there are a minimum amount of memory used. We used the animation controls to animate on this one. So you can drag around the head and you can open his eyes and do all kinds of crazy stuff. We drive this with driven keys in Maya, connected to each of these float attributes. Now that's a big driven key tree, I can tell you, but you have to do it once, and it is pretty straightforward once you get into it. I can really recommend this. You modify each pose. So once you have recorded all this animation data, we used a lot of facial recording software. So we had our actors sit down and talk in front of cameras, and then this would get exported, and we would get these float channels animated. So what if we wanted to reuse this animation on some other character? In multiplayer, you could have your own character, and you would customize him, but you still want him to say the same line. And you still want it to look good. You don't want the facial joints to twist his head back. Then you use this tool to customize. For Jeffrey the Third, or whatever his name is, I want to customize his jaw open to make it Clint Eastwood style, or I want him to, his lips should be always a bit rotated. The facial animation will then drive these attributes, give him a specific look. So it's a really simple concept, and I urge you to try it and Google it. It has really helped us a lot. So, I talked about recording this facial data. This is how we did it. We actually recorded all the data simultaneously. We have the body, the facial, and the audio.
Gentlemen, we're looking for any sign of al-Bashir. Find it, bag it. You guys, clear the basement. We'll sweep the rest of the building.
Roger. Blackman, come on. Montez, door.
And the cool thing about recording all this in one take is that you actually get a believable experience. They are actually doing this and saying this and performing it all in the same time. Oh, thank you. So, once we get all this, I can't see you guys. Oh, there you go. Oh, thank you. Once we get all this recorded data, it's a huge amount of data. It's body data, there's facial data, there's audio, there's so much data. We use a tool called the Clip Manager in Maya. This is our universal animation tool. It is pretty simple. It lists all the animation curves in a folder, and we keep all the animation separate from the Maya file. And this is also a key takeaway. If you are animating in Maya files, even if it's a referenced rig and you're animating, just saving it and closing it, you are pulling yourself into a corner, I would say. If you put this data outside of Maya, it means that you have the tool, you have the communication. You can say it, okay, when you're re-importing left hand IK37 translate X, I want to re-output this to some other controls, or I want to multiply it by 3. You have control over the animation data. It also means that you, in one big button, can re-export the entire game. It's going to take a while. It takes like a weekend. But you can push the button, it will go through 6,000 animations. Reapply it onto the rig and export it out. Totally awesome. It is connected to Perforce. So the animators can just double-click it, save it, check it in. It is integrated with the motion capture tool, so when we get the data from the motion capture, you just click the little blue guy in the corner. It will bring in all the motion capture. It will snap the rig to it, bake it out, and it's super, super fast. And you have the right click in Maya. That's awesome. Just a little side note. Just to make it fast to work with. And this is really key to the production, keeping it simple. So, we learned a lot doing this. It's a huge project. It's tons of animations. So it's super, super good to learn. We learned that Python is the most awesome thing in the world. I only wish I started sooner. But if you compare Mel scripting to Python, it's no. Do it. If you haven't learned Python in Maya, do it. It's never too late. We are going even more modular. We are making smaller modules, and we are making more modules. Right now, our modules are they work, they're good. But to make it really, really awesome, we are going to make them smaller and make them reusable on even more kinds of places. And when you have these small modules, we want to make them easy to use. So we still have the same workflow as we do today. We want the animators to be able to drag and drop. Okay, give me a head, give me an arm. And it should make sense. Okay, you always do the arm and then the head. Make it easy. We want to make it super interactive. If anybody has used the automator in Mac, I recently discovered this. It's pretty much the same thing. It's pretty cool. You can drag and drop different actions onto it. Oh, and it works. It's awesome. And to make sure that this is always, always working, we've actually just done this. We've set up build farms connected to our, the programmers use the build monkeys to generate solutions for Visual Studio. So we use a bit of their reserve. Whenever we are checking in a new change list or modifying a Mel script a Python script. That's old habits there. But now it's Python script. So whenever we are changing it, it triggers a little monkey computer somewhere to build everything. It builds a whole bunch of characters. It builds all the weapons. It combines it together, apply an animation, export the animation to the game, and it then compares the result. Is this animation different than it was before this change list? And then it will stop an email and error and stuff. So that's also super awesome to make sure that your tools are always stable. Whew. I think that is it. Yes. 1 minute. Right. If you have any questions, shoot. There are microphones. I'll be here all week. If not, then thank you very much.
Hello?
Yeah?
Do you have a system that combines equipment and head and character? Do you export different parts into your editor and then at game time it combines them, or do you just have one guy? He's one draw call, or do you have 5 pieces on your character and they're all different materials?
If you're referring to the Maya part, because the components are mostly made in Maya, so it's for taking all this Maya an IK, FK, or 2-bone IK, and those are the kind of components that we are taking together to a piece, to generating one big animation file.
Okay. I'm speaking more on the character end. When you import the game, do you import the character all as one guy, or do you do the equipment separate and the head separate and the body separate, and then combine it in the game?
No, we have everything combined.
From Maya to the game?
Yes, from Maya.
Okay.
So we use the character builder tool to make ourselves a big skeleton, to make ourselves a new combination, which we then export, and then we apply the animation on top of that. So there's not modular in the game.
Okay, cool. Thank you.
No problem.
Hey, that was a great talk. And I'm wondering if you could talk just a little bit about your division of labor on your tech artist team. How many folks did you have, and what was their skill set, specialties, and anything you want to share about the team on that?
About the organization.
Just about the tech art in specifically.
We are 2 tech animators on DICE. At the entire studio, we're about 250 people. So we're a minority. But we have a good set of animators. I think we're 15 animators. So we're 2 tech animators. And since this workflow and these tools have been ongoing for the last 5 years I've been there, we have started small and scaling up. So we're actually not more than 2 people.
Thanks.
Can you talk a bit how you take the video from the performance capture and transfer it as a facial animation?
Absolutely. From the performance capture, we get a huge FBX file, which contains everything, and we do a normal FBX import into Maya. We then have a mapping script that says, like, when I'm importing the FBX file and I have selected the right hand is checked. Okay, the right hand control is constrained to the right hand joint. It will then look for the right hand joint in the motion capture skeleton. So basically, the selected controls will pop to your animated, and it will do that for every frame and bake it out.
Yeah, and for facial animation, you grab video from...
Oh, yes. Oh, yeah. For that, we use a third-party company who do all this analyzing for it. We have tried the image metrics and those kind of facial analyzing techniques, and we're reusing something very similar. So it's basically looking at every frame, analyzing it, and what it does is it takes these animation controls, and for every frame that they're analyzing, it is pulling every single control in the entire face until it finds a match. It's really weird, but it works. It's pulling everything until it's the closest match. And the system, for every thing, it actually learns, okay, when it was this frame, it was the fastest way to go here is like through these poses. So it's actually pulling all the controls. So we get the animation onto our animation controls. Oh, good.
Why Maya? Why didn't you use Motion Builder? Because it's mocap. Would it be more straightforward?
So the question was...
We're actually out of time at this point, so thank you for coming. We're going to have to break and set up for the next session. We appreciate you coming.
All right. I'll be here, so come by.